winner. Ooh, this is Heather. You want to come up in front of the room?
What's the base of it on that? Nice. That's my stuff.
Next is this one. This is Chris. Ooh. Yeah, it's very cool. Go. Two more. Everybody's in eager anticipation, I know. Jacob. Is that surprising? What? Ooh, exciting. Yeah. I'm losing my mic again. Where is he? Not here. Finally, we have Happy Fish. I like the Happy Fish. This is Michael. This is Lek. The Happy Fish spoke to me. So, the final winner is the fish. Okay. So now y'all want to go in and finish problem set 5 and do it. More. There'll be one more contest actually coming up in addition to 5, which will be 7, the game. You guys will be doing an adventure game. So we'll have a contest on if you want to extend the adventure game and do all sorts of cool things, and then we'll judge those. We have a new special form that we're going to see today. Set bang. And set bang takes a name, and it takes a value. And what it does is it evaluates this. It could be an expression. It doesn't have to be a value. Evaluates the expression and then assigns its value to name. Now, how is this different from define? So let's say we define A to be 100. So we've got some slot over here in memory, 100. Now we can say set bang A 200. And that will change its value there. Okay, you may still ask, how is this different from define? Because couldn't I have just said define A 200? And in this case, we could have. But what set bang is going to allow us to do is to change variables outside of our current scope. Right? So, well, they're within our current scope, but it's going to allow us to change things. We'll see. Let me go into the bank balance, and we'll talk about how set bang could be useful. Now, before I start talking about how set bang can be useful, let me talk about how set bang is not going to be useful. For all of you C programmers out there, you are not going to start using set bang all over the place for assignment. Check? Check. We are not going to use set bang all over the place. Okay, we are not going to start using this as a general sort of assignment. We're not going to write factorial using set bang, even though they do in the book. Okay, that's nasty, nasty, nasty programming style. Bad. Keep using the recursive calls the way we've been doing it. Don't follow the book on factorial with set bang. It's bad. Okay, one more thing about set bang before we actually look at using it. This has an unspecified return value. And thus, this should never be the last expression that you guys have in a procedure. This should not ever be the return value of a procedure or of anything, because we don't know what this is going to actually return. In our scheme system, it appears that it actually returns the old value of A. Very useful. So we're not going to actually want to use set bang as our return value. So let's actually look at a case of using it.
Does name have to exist? Can this also create an initial define?
Name has to exist. So let's look at creating a bank. John and I have decided that we're just not making enough money, so we're going to start running a bank, because that's clearly the way to make money nowadays. So we're going to make a bank, we're going to get somebody to buy us, and we'll be fine. So we're going to write our code for our ATMs. So we're going to define a balance as being 100. And now I'm going to write a procedure to deposit money into that account. So I'm going to have deposit and some amount. And what I'm going to do, what I want to do is I want to increase my balance here by amount. So what I can write is set bang balance. I want balance to be updated to be the result of adding balance to the amount. Set bang's a special form, just like define is. So what set bang does is it evaluates the expression first. So in this case, we know that that will be evaluated first. Thus, we'll be using the current balance, add the deposit to it, and then we'll update it with a new balance. We'll put that new amount into balance. Now, remember I said we don't ever want to pass back the result of a set bang, so we'll return balance as a result of our procedure. Okay, because we don't want to just end it here, because we don't know what set bang is going to return. And that's just going to give us some weird behaviors probably, especially if in our system it's returning the old balance. Your user may be a little annoyed if they know they have a balance of 100 and they deposit $1,000 and then you tell them 100. And you're like, the bank's eating my money again. So we should return the current balance. So now let me write a procedure to make an account. How does it know which balance? It's in a different environment. And actually, so tomorrow, finally, I know I've been promising you guys for so long, tomorrow we do the environment model. Yay! And there's much rejoicing. And okay, so basically, it's the same rules as before. If we're in this procedure and there's no variable scoped here, then we look out into the global environment in this case. And there is one defined up there. And we're going to see this really clearly tomorrow because we're actually going to draw the environment frames. And you can see where the global environment is and where the subframes are for the procedure.
So another balance inside a procedure parallel with that. It wouldn't get to it.
Right. So if we had defined here, if we had defined a balance here, then we would be changing this locally scoped one, not the one out in the global environment. That's exactly right. Take that out so we have the code like it is on the handout. So I'm going to make an account. What I want to do to make an account is I want to pass it some initial starting value. So like when you open your account at a bank. So we're going to have some starting balance. And the first thing that I want to do is I want to update balance to be my starting balance. And then what I want to do is I want to have my make account return a procedure that when I call it later on, I can deposit money to my account. This is going to be a one-trick pony of an account. All we can do is deposit money to it. This is sort of like the forced savings plan. We cannot withdraw money from this account. So I'm going to write the procedure lambda amount. And what this is going to do is it's going to set bang balance plus balance amount and one final thing for this lambda is that we don't want that set bang to be our last expression. We don't know what its value is, so let's just return the balance. Okay.
We could have returned deposit there, right?
We could have returned amount, the amount of our deposit.
I mean, instead of the whole lambda, could we have just put deposit?
Sure. Sure, we could say deposit. Anybody see? What if we said deposit instead here? It's exactly the same, right? That's what deposit does. Because deposit, if we desugar this, says deposit lambda amount. And then the body's exactly the same. So that's exactly right. We could have just said deposit instead, and it would return the same thing.
And is there, this is just something I've gone back and forth on, is there a reason that it's preferable to do it without defining, or without calling deposit, but just kind of implicitly putting the lambda statement in? Or is that just a matter of style?
Well, here I want, let's actually follow through in evaluations, because what I want is I want to be able to call, I want to make an account. We'll define an account to be my account. And what I want to be able to do is call my account and just deposit the money in. So let's follow one through to see what that means. So what I'm going to do is define Holly account to be the result of make account, and I'll start off with, what did I say, $200. So give myself more? I don't know. Okay. I'll give myself $1,200. Woohoo! I'm rich now. Pizza for all. Okay, so what happens on this? Well, it's a define, which means special form. We're going to evaluate this compounded expression and then bind Holly account to the value of the return. So we're going to call make account on 1200. Well, the first thing that we're going to do is we're going to do a set bang of balance. So let me actually just create a slot over here for balance, so we'll have some place to keep track of what its value is. Well, right now in our environment, it's 100. So we're going to set the balance to be our starting balance, which is 1200. And we'll just cross that value out rather than erase it so we can see how things are progressing. Okay, so we've set bang balance to be 1200. And now I return a procedure. So Holly account is going to be bound to a procedure that takes in a parameter amount and does set bang balance plus balance amount and then returns the balance. So the reason that we're returning a procedure here is now what I can say is Holly account, let's give myself $1,000. Okay, so Holly account is a procedure now that takes an amount, and it's like a deposit. So now when I call Holly account, I'm making it deposit into Holly account. Okay, so that's why I returned a procedure, because now I can just apply the name Holly account, which is bound to the procedure.
So it's kind of you could do it the other way and just, but then you'd have a lot more syntax when you wanted to make a deposit.
Right, we could do it so that we'd somehow, what we could do is we could have deposit where deposit takes an account and an amount. But in this case, all we have to do is say the name of the account and then the amount that we're depositing. Okay. So what's going to happen when I call Holly account on 1,000? Okay, so it's this procedure here. We're going to set the balance to be the result of 1,200 plus 1,000, which is 2,200. And then it returns the balance, so it will return 2,200. Yes?
Wouldn't it actually be easier to define it so that you could just do Holly account plus 1,000 or minus 1,000 now?
Well, in fact, the way we do have it written now, we could do that. Right? I could actually just call Holly account minus 1,000. So in fact, what I said about being forced to do deposits, well, if you enter a negative amount, you're actually making a withdrawal. So that would take the balance, and it would add negative 1,000 to it, and that would bring us back down to 1,200. So yeah, that would work exactly the same.
Just to be quick, you don't have to put that in parentheses.
No. If we're putting a minus sign in front of a number, we don't have to. But if it were a variable, then you would do minus space and then the name of the variable. But for a number, we can just write -2. So we're allowed to do that. All right, so we can actually make withdrawals. But if we don't tell our user about this convenient feature of putting a minus sign in front of anything, now it's an enforced savings account. All right, so here's our happy little bank account. Now, let's say John comes to my bank and he wants to open up an account too. So we're going to, let me erase these here to get a little more room. I hear that's not so good. Why is that not so good? Does John not have enough money for my bank? Because we're sharing a balance. Exactly. What happens if John comes in and opens up an account with $500? Do we have $1,700 or do we have $500? Make account is this procedure over here, and the very first thing it does is it changes the balance to be the starting balance. Whack. Well, I, as primary shareholder in the First National Bank of ADU, am very happy about this because I just gained $1,200. However, my people using the bank may not be so happy about this outcome. Does anybody want me to go through exactly how this happens, or you see how this is happening here, the set bang? So now, when John has his account, let's say John is depositing $1,000. Well, then this is going to return, this will update over here to be 1,500. This will return 1,500.
Why does your John account affect Holly account?
Because we only have one balance. We only have one balance. And so we're changing this one balance regardless of whether it's John's account or Holly's account or anybody else's account that's opened in the bank using this make account procedure. Yes?
That's a bug.
That is a bug. And that's why on the next page it says, can we fix this? In case you were missing it, this is a really bad idea. This is going to cause our bank to fail, and Fleet will not buy us. We will not make any money, and thus will be bad. Okay, this is a bug. Yes, good. All right, let's fix the bug. How could we fix the bug? I missed some joke about Microsoft. I'm very upset. I heard something about Microsoft. Ha ha ha. All right, so what I'm going to do now is I'm going to rewrite make account. And make account is going to take in a parameter balance. Now, this means that the procedure is going to have a local copy of a variable called balance. Yay, this is good. So, let me define our account to actually have the ability to make withdrawals without having to go for John's negative method. Right? Because we want our user to just be able to say, I want to make a withdrawal. This is the amount. We don't want them to say, I want to make a negative deposit, because that's not good. So let's say we're going to define a procedure called withdraw amount. Notice that I'm scoping this procedure underneath this one. And that means that this procedure is going to be able to see this balance. See the balance from the parameter here. This will be a local variable within this defined make account. So any procedures underneath here are going to be able to see that variable. So withdraw, we'll do what? Set bang, what to what? Balance. Okay. Minus balance amount. Good. Do we want to return that as the value? No. Sure, I say it 8 million times in lecture, and you guys are going, God, you say this over and over again. But you'll go to the computer someday, and you'll forget. And you'll go, oh, yeah. So let's define deposit to be very similar. So we'll have set bang balance to be the result of adding the balance and the amount. And I'm going to write balance. Okay. Finally, what I'm going to do, because I do have a couple of procedures in here that are scoped within our make account, is just like the old make account is I'd return a procedure so we could just operate on it. What I want to return now is a procedure that's going to allow me to select if I want to make a deposit or make a withdrawal. And I'm going to call that dispatch. Which will take in some M. And M is going to be a symbol, either withdraw or deposit. So our user can say whether they want to make a deposit or withdrawal. So what I'm going to do is test to see if M is EQ to withdraw. And if it is equal to withdraw, what do I want to return? Just the withdraw procedure, withdraw. Next, I'm going to test, is it equal to deposit? And if it is, deposit. And if it's not equal to one of those two, then the user's told me to do something I don't know how to do. So I'm going to return an error. So I could say undefined operation. I should say dispatch. Dispatch M. Thus closes dispatch. Okay, so now I've got three internal procedures here. What do I want my return value to be for make account? When I make an account like this, if I call define Holly account, make account $1,200, something needs to be returned to be bound to Holly account. So we're going to return the dispatch procedure. Okay, so let's follow through evaluating make Holly account on $1,200. So we evaluate make account $1,200. Balance gets passed in. Now, I said there's a local copy of balance. We're going to have to do this rather informally right now. Tomorrow, finally, we need a nice formal way to draw all of this out so we can see it. But let me just say what we have, balance from Holly account. Okay. This is not a nice, neat way of doing this. Tomorrow we'll see a nice, neat, beautiful, wonderful way of doing this called the environment model. Okay, so you believe it when you see it, I know. It'll be great. Trust me. Trust me. Okay, so as soon as the procedure is called, balance is going to be bound to $1,200. So let me put that there. Okay, so now we define a couple of internal procedures, withdraw, deposit, and dispatch. And we return dispatch, and that's what Holly account is going to be bound to. Holly account is going to be bound to dispatch with this balance. This is where the substitution model is starting to fall apart on us, right? It's hard to sort of keep some notion of internal state, local state with the substitution model, right? There's no neat way to write that dispatch has balance bound to $1,200, and that's what the environment model tomorrow is going to allow us to do. It's going to give us a neater way to do that. Okay. So dispatch, remember, is a procedure that takes in a message and then checks it. So now, how would I make a deposit to my account? Holly account deposit.
That's your operator.
Let's say I'm going to put in $500. Okay. Why do I have a set of parentheses there? Right. So Holly count is bound to the dispatch procedure. The dispatch procedure is a procedure of one argument. And that's going to either be withdrawal or deposit in this case. So we pass it deposit. And so dispatch does is it takes this message and it checks it. Is it equal to withdraw? No. Is it EQ to deposit? Yes. So it returns the deposit procedure. So it returns us this procedure here. So now we have a procedure that takes in an amount and does a set bang on balance of plus balance and amount, and then returns the balance. So that's the procedure for deposit, and that's being applied to 500. So 500 gets substituted in for amount, and we set bang our balance to be the result of balance plus amount. Now the balance for the Holly account is $1,200. We add $500 to it, so we update this to $1,700, and then we return $1,700. Okay. Questions? Yeah.
So we're now in a situation where you can differentiate between Holly account and John account because of the balance there. But
Right.
What if you have the same balance? Wouldn't it make more sense to tag by person? To add a tag for a person?
Well, okay, so we could have, you mean, if we had the same balance amount, or
Well, what happens if John has 1,200 too?
it'll be a different 1,200. Okay, so basically, when we call make account, there's a variable called the balance created. And that variable that's created is local to that particular call of make account. When we call make account a second time, there's a new variable called balance created. Okay, so the first call with Holly is going to make a balance, and that'll be, my account will be able to access that. If we call this again for John's account, there will be a separate balance only accessible by John's account. And tomorrow we'll take this very same code, and I'll show you guys how we can totally evaluate it in the environment model to make this very clear. You'll see that there'll be a frame for John's account where there's a balance there. It'll be called balance, but there'll be a separate frame for Holly's account, and they can't access each other. They don't see each other. So it doesn't matter if we have the same balance amount because they're not going to be able to see each other. Yes?
Will this happen as long as, let's say, I return some procedure from my defined procedure?
Okay, so the question is, will this happen as long as I return some procedure here? So the idea, exactly, the idea is that you want to keep something here. You want to return something here like a procedure object, because that's what's going to allow us to remain in that sort of state.
Keeps balance from being garbage collected.
Exactly. It keeps balance from going away. Because if instead of returning dispatch here, we return balance, as soon as we exited that, it'd be gone. All that state would have gone away. Okay.
When you run make account for the first time and associate with Holly, how does it set up the account? It returns the procedure, but does it make an account with that initial balance, 1,200? Where in the code does it do that?
So there's no initial set bang balance like we did in the last make account.
Yeah.
That's coming in sort of as a fringe benefit of this parameter. Because when we call the procedure, what happened,
It just associates the 1,200 with balance.
right, $1,200 comes in, and then balance is bound to that in this environment of make account.
You don't even have to set it.
No, we don't need to set it. It's right there. There's a balance variable created. 1,200 is bound to it. I'm going to scan this way, and I'll go back that way.
Two quick syntax things. First, how come we use EQ question mark instead like equal or EQV?
Okay, we used EQ because we're checking symbols. Okay, and EQ is going to work on symbols because we're going to have a symbol table where each symbol only exists once. So symbols are going to be EQ. That's our pickiest test. We could have used EQV or equal because remember, it's the picky. If the pickiest one is true, then everything up the scale is going to be true.
I just wondered maybe in some funny scheme withdrawn wouldn't be equal.
No, that's not the case.
And second,
Mm-hmm.
should there be a fourth parenthesis at the end of the dispatch M? That's very far, right?
Yes, there should be. You can take points off, but I didn't take points off on the exam for that for you guys.
If you define another Holly account with the same name, you won't be able to access the old one.
Well, what happens generally in Scheme if we redefine something? So if I were to define A to be 2, and then down here I define A to be 4, right? This one goes away because we just do a new binding up for A. It'd be exactly the same thing here. And it would lose any money that was in there. So it would rebind it, and anything that was in the path of the older state would go away. Yes?
When you make a second deposit, how's it getting the 1,700 instead of the 1,200?
Because when we made this deposit here, we did a set bang. Okay, so this make count has that local copy balance. So what we did is that we made this change using set bang to balance from 1,200 to 1,700, and that's what's in the variable now in our local frame. So set bang did that for us. Yes?
What would the difference be if we would have, instead of using set bang, we would have defined balance?
Redefine.
Where do you want me to define it?
Well, for example, on the
So instead of just here?
yeah. What would the difference be?
Okay, so what's going to happen if instead of set bang, I use define? Does anybody have any sort of feeling for that? Thoughts? It's going to be, this define here will be scoped within this procedure. So when we execute this procedure, when we evaluate it, balance will be created to this. But as soon as we exit out of deposit, it's gone. Okay, so set bang is allowing us to change the balance that's out here in an environment that isn't going to go away when we quit evaluating the deposit procedure. We'll quit applying
What
that.
is the domain of set bang then? I mean, would this define would be scoped only within the procedure
Right.
that's defined for them? How far out does set bang?
What set bang will do is it'll look in its most local environment and say, is there balance here? And if it can't find it, then it looks up in the next scoped environment. So in this case here with the set bang, let me change that define back. So in this case, it's trying to set bang balance. Well, within deposit, there's no variable balance. So now what it does is it looks out to the next level out here. And here it finds that we had defined balance there. Okay. If for some reason we had not called this parameter balance, let's call it S balance, now it would go out and look in the global environment and say, is there a balance out there? And if it couldn't find us, it would give us an error. Okay, so it's just going to keep looking up the chain. And this will be the chain. I keep promising you guys this tomorrow. You're going to go, this is not all it was supposed to be. But tomorrow we'll see how the frames are going to be chained to one another and how it's easy to follow the chain up to try to find that. Okay. Yeah, I know. You guys don't believe me. I promise so much.
By set bang becomes scoped by whatever's the most local occurrence of that?
So set bang is going to change the most locally scoped copy of this. So it's going to look in its current procedure, and then the one that's scoped around it, the one that's scoped around that, and finally ending up in the global environment. It's just going to go up the environment chain.
These procedures are tied to the account also. They're saved along with the account.
Yes.
So every account has the procedure with it.
Right. Every account would have a copy of the procedures with it. Yes.
The crucial differences between the buggy one and the non-buggy one is the balance is now defined as a formal parameter rather than go in the global environment.
Right, right.
The messaging is sort of like a red herring. We were returning a lambda procedure before.
Right, we were returning a lambda before. It's just that we have a locally scoped copy of balance. So in fact, if you look at the one on the first page, if we were to change make account from taking starting balance to just taking balance, then that would have been okay.
So with this, the first line that says set bang balance, maybe the first line would have had to be rewritten also?
I'm just wondering what the noise is out there. So basically, you'd either have to...
You wouldn't need that first line.
What you would do is where it said define make account starting balance, is you could just define that to say define make account balance. And if you said that, then it would be a local copy of balance, and then my balance would be distinct from John's balance. So it kind of fixed two things at once. Right, because John had said, oh, we could just have a negative deposit. But we don't want our user to have to think of, oh, it's not letting me withdraw, so let me do a negative deposit. We don't want people to have to start thinking that way in our bank.
Is there any way that you could have called withdraw deposit without using message passing? Are there any options?
Well, we still need some way. We're going to have a withdraw and a deposit, so we're going to need to have some way to select which procedure we're going to use. So since we're going to have to make a choice, we'd have to pass something in to make the choice. Okay. So the message passing is as good as any. You know, it's probably far clearer to pass in this symbol like this than to do some sort of selection where if we do we call the account with the number 1 and then 500, then it's going to do, this is a little bit clearer. And in fact, passing it with a number 1 is still effectively message passing, but less clear. Okay.
I didn't even catch that. So the only functional difference, the thing that made this work was just...
The thing that made this work is this. Okay. So, but because I decided to add in a withdraw procedure, now that we had withdraw and deposit, I couldn't simply return deposit anymore because then I'd never have access to withdraw, which is why we added in the dispatch procedure here that allows us to access either the withdrawal or the deposit mechanism. Yes?
My intuition on how to solve this problem would be just to have Holly account and John account be variables that identify numbers with balances, and then you would pass those into a deposit procedure that would take that variable and an amount and combine and add the amount to whatever the variable represents. Is there a way to do that?
Okay. So the question is, let's say we define Holly account to be the amount. So when I open it, I would define like that?
Yeah.
Okay. So then let's say I have some deposit procedure. I'm going to define it. So we'll define deposit on an account for an amount. So what do you want the body of this procedure to read?
Well, I was wondering if there's a way to use setbang to scope outside of this to change Holly account.
Well, certainly setbang can scope outside of this, but the problem is that when we call whatever this body is, if I call deposit on Holly account of 200, what happens here? All right, this will be evaluated to be the number 1,000. And we're going to lose all ability to do a set bang at that point because it's not the variable anymore, but the amount 1,000.
If you passed in the symbol, Holly account,
Okay, so if we pass in the symbol, Holly account, well, it wouldn't evaluate to 1,000. But would it be the variable Holly account anymore? It'd be the symbol Holly account. Right? So.
But if you ask the bank to make a new account number for Holly account, number 1, 2, 3, 4, that's your first transaction. Your next transaction is to put $1,000 into it. It'd be like having a password and a number. It'd be like building a table. be a row for each account number and a current balance for each person?
If then every time we did an update, you wanted to re-update the table by using put. All right, so we'd have to use put to put the new balance in the table. So Todd's question is, just like in the generic operators, instead of having the side being the operator and this side being the types, why not have this side be the account number? And then this side was going to be,
Could be the balance.
right. All right, so in fact, all we need is a 1D table.
Unless you want a record of transaction.
Right, unless we want a transaction record, sure. So then what we could do is, instead of a set bang, we could have a put 1 if we had a single table. Well, we could put 1 balance, I suppose. I'll put 1 balance plus account amount. Something like that.
Wouldn't that also have the advantage that you'd have, as this application went on and you had lots of users, you'd have far less kind of far less stuff out there in the environment because you're just putting this stuff in a table as data rather than having it all hanging around in the environment as procedures. On the current system, every account has its set of procedures to find and so on.
I'd like to say yes, but with the but being, this is pedagogically nicer. That's just a bad answer, right? You know, it's when you go up and hit the teacher. John wants to say something.
If you have a database of some sort, like you're suggesting with a set of accounts, something like that, then a table like this might well be the way you would approach that. But the approach that we're using here to capture state is far more generally useful, and is especially useful when you don't have the series of identical values that you're trying to have. And you'll see in the next problem set,
It seems like looking at the table, like maybe it looks kind of equivalent with what we've done so far, but it seems like you'd have to just be continually adding columns to the table for each.
We could have to keep adding columns to the table. The other thing, too, about having local procedures here is that I could now define different types of accounts. And maybe Holly account, because I was one of the first 100 accounts in the bank, I'm going to get a higher interest rate. So then I would have different local procedures than other people would. So that would be one thing that we could do that way. Any more questions on this before we move on? Yes?
I'm still unclear about Chris's original question. If define deposit account amount, and then you basically just have a set bang account plus account amount. I don't see where that says and then return account. I don't know why that doesn't matter.
When we call deposit, we're going to pass it the account. This will be Holly account.
Right.
And then the amount that we'd like to increase it by. But Holly account here is not a procedure. Holly account is a variable. And the way that scheme works, remember, is that we're going to evaluate the parts of the sub-expression in any order. So we're going to evaluate Holly account, and it's going to return the number 1,000. Okay, so when we come up here, it doesn't make sense to do a set bang on the number 1,000. It's no longer the variable for Holly count, but the number 1,000, and we can't do a set bang on that. And that's the problem with this approach to it. Okay, so I've written my account over here, and I've now learned that my bank is bleeding money. Why might my bank be bleeding money with my make account written like this? Yeah, we never check to make sure that people have the money to withdraw. This is a big problem, right? We probably want to fix this because we're gonna lose a lot of money here. Because once users figure out, hey, I can take out whatever I want, and the balance will just go negative, they'll be like, cool, let's just keep going. So we need to rewrite our withdrawal procedure. I'm going to check it. So so, sure. Well, let's say if the amount is less than the balance, or we could say balance greater than amount, doesn't really matter. What I want to do if the amount is less than the balance, it's okay, we can make the withdrawal. So we're using an if now. What if I said set bang balance to be the result of subtracting amount from balance? We have some sort of weird unspecified return value. So we're going to see another special form right now. And that's called begin. You guys aren't going to use begin a lot. Okay, begin is going to be used to allow us to string some expressions together in a place where normally Scheme would be looking for one. So as the consequence of an if, Scheme expects one expression. So this is a way that allows us to make more than one expression into one. So begin's format is begin, expression 1, expression 2, expression n, like that. And the way begin works is it will just evaluate these in order. First expression 1, then 2, all the way up to n. So it'll do them in order. It's just like a neat way to put kind of an extra set of parentheses around them to group it, but we need the word begin there to tell Scheme that's what we're doing. Yes?
Consequences also require begin?
No, the con doesn't. Because remember, the cons, we can have multiple things. So in the cons, we have some sort of test. And then we can do any number of expressions we want here. So the con, in fact, has an implicit begin in it. It's going to allow us to do multiple expressions here. But the if doesn't, which is why I'm using the if here to show you guys a new special form. But if we had switched this over to be a cond, then we wouldn't need the begin.
And then let, you can have as many, obviously that's a body.
Right, let is a body of a lambda procedure, so that can have as many as you want.
And define you can have.
Right. One place that you might also need to use begin is in a cond. This test here is only one expression. So if for some reason in your cond you wanted some series of things to execute for your test, whether it could be like a set bang and then you return the value or something, then you would use begin here in your test. So the two places where you might need, need to use begin. Yes?
If you were to sort of define begin, what would it look like? I mean, like if you were to
You mean if I were just to say,
create begin as a procedure rather than a special.
oh, okay, so if I didn't make begin a special form, but instead it was a procedure?
Yes.
Okay, if it were a procedure instead of a special form, all bets are off as to the order that we're going to evaluate our expressions in. So it buys us the ordering. That's what the special form gets us. Usually the special form just gets us the special rules, usually some special order of evaluation. So that's what it's buying us, is that we know it's going to go 1, 2, 3, up to n. Whereas if it weren't, we wouldn't know what order they were being evaluated in. So if expression 2 depended on what we did in expression 1, we wouldn't know if that would actually work properly.
I see. Okay.
So it just preserves the sequencing for us by making it a special form. Other questions? So that's begin. Begin is also listed on page 1. It talks about begin. Okay, so we're going to begin. And the first thing that we're going to do is we're going to do our set bang. And we're going to set our balance to be the result of subtracting amount from the balance. One, 2. And then I'm going to return the balance. Okay, so that ends my begin statement. And finally, I need to return something if they've tried to ask for too much money. So there's two things that we could do. One thing is that we could error out, or one we could just display. In this case, I think I would prefer to go with a display rather than an error. You just want to tell your user they were wrong. In this case, you're going to put an error out because they've entered something wrong in the message passing. There's probably some calling procedure that's messing up here. But in here, we probably just want to tell our user, hey, you know, you made a mistake. Excuse me? Huh? You subtract the bounce fee, yes. We have now taken $100 from your account. Thank you. You only had 20, but we could withdraw more than you could. This is good. We'll make a lot of money this way. I like this. So we'll keep going down and down and down. So in this case, we could display.
Are we still in the begin?
We're out of the begin now. This one here, because balance doesn't need to be in parentheses. It's just the variable. We're just returning its value. So that closed off the begin. So we could return. We could make a list of amount, and then the symbol exceeds, and then the variable balance. So if we try to over-withdraw an account, so let's say I define Holly account to be make account of $100, and then I try to withdraw $500. What's going to happen here? Oh, we go into dispatch. EQM withdraw, yes it is. So we return the withdraw procedure. And then we were going to apply withdraw to 500. Withdraws here, it takes in an amount. 500 is not less than 100. So we evaluate this, and we return the list of amount, which is 500. The symbol exceeds, and then the balance 100. Okay. We also could have used 3 display statements. That would have been fine too. But I ran out of room, so we used a list.
Could you do if less than amount balance, set just your set bang, not return balance yet, and then in the other case list some stuff out, and then return your balance after the if statement?
Sure. So the question is, if we took this out and that out, so this is the only consequent of our if, and then here after our if we said balance. We could do that, and we wouldn't need to use the BN. It might be a little bit weird in this case, because we would say 500 exceeds 100, 100. So it might be a weird sort of return value for our user. But certainly, we could do that, and then we wouldn't need to have the BN, because the set bang here wouldn't be the value. It wouldn't be the last thing evaluated, because we had the balance after it. Yes?
What happens if someone tried to get around this by depositing negative money?
You'd have to do the same thing.
Would have to do some sort of check here to make sure. Make sure that deposit is positive. Right. So we could do the same sort of thing where we could say if amount is greater than 0. Then we'll do the same sort of thing. Yeah, exactly.
You would actually get an unspecified return value returned, though, if you did it the way without the begin, right? When it evaluated the if.
No, because what's going to be returned from the body of the lambda is the last expression that's evaluated. So this wouldn't be the last one to be evaluated. Balance would be.
So if you did do a withdraw more than you had, you wouldn't see the list.
You would.
Either.
Exactly. That's right. We'd have to do a display there. The list wouldn't come out either. Right. So we'd have to change this to something with display. And then it would have to be 3 displays, because it had to be display the variable, display the string, display the variable. Okay. So, yeah. I think this one's nicer with the begin. Okay, so now our users are a little pissed at us because they can't withdraw infinite amounts of money. What they told us is, well, you know, you're not giving me any way to find out how much money I have in my account. You know, I go to make a withdrawal, but you won't tell me how much I have in an account. So our users are demanding a balance procedure. How would we write a balance procedure? And where would we put it?
First we put it in dispatch.
Okay, we could have something in dispatch. EQM balance. Okay, and if it is, then we're going to return some procedure. We could call it.
Not bad, okay.
Could you just return the balance?
Oh, actually, yeah.
Color balance.
Good. We could just return the balance. We don't need to have a procedure, do we? Right. Because we have the balance. There's nothing we need to do to operate to get the balance. It's there. So we can just return it. No procedure necessary. Just return the value. So now, if I want to find out what I have in my account, I would say, would I say it this way with double parens? I hear no, exactly. We want to have single parens because balance is not going to return a procedure. It's not returning something that we can apply. It's returning a value. In this case, it's going to return 100. Now, we could make arguments about why it might be nicer to actually have balance be a procedure. Because all of a sudden, in some cases, we're using double parens, and in some cases, we're using single parens. No argument, you could just put double parens around it, which is a little weird too, right? So it's sort of a weird. We might want to build something on top of this, providing us a nice abstraction for actually doing this. Yeah. We could provide some sort of abstraction that would allow our user to just say deposit and pass in the procedure for their account and then the amount, and then it'll go off and spin off and do everything if we split it all up properly. But for now, we can just assume our users are smart. Or we could assume that our ATM is going to handle that for us. Right? They're going to push the little deposit button, and that'll go off and do this. Well, okay, I picked the one that I don't have up there. They press the withdrawal button, and this will happen. They press the balance button, and that will happen.
So it's a hardware problem.
Yes. No, well, it's not really hardware because we need to control what happens when it's pushed, and they'll call some software thing and some sort of interface. It's an interface issue. It's an interface issue. Yes, that's the other people who are working on this. So before I erase this, any questions? Obviously, you guys can come and ask me about this more if you want, or John, or even John knows about set bang. Okay. So we did set bang. Check. Now we're going to mutate lists. Mutating lists is fun and exciting. So let's define some lists. Let me pick the ones off the sheet for today. Okay, so we're going to define the list X to be a list. I'm actually going to change it slightly. The list of quote A, quote B, and the list of quote C, quote D. Okay, so X is going to be bound to this box and pointer diagram, which has a top-level list of 2 elements, with the first being a list of 2 elements, A and B, and the second being the list of 2 elements, C and D, and that's bound to X. So there's X. So now, let's define Y to be, let me write it over here so I keep a clean area for my box and pointer diagrams. Y is going to be the results of consing X to the coulter of X. Okay. What is X? This. So Y is going to be a consel with the car pointing to X. And with the coulter pointing to the coulter of X. Why didn't I copy the list structure? Why didn't I rewrite the list structure? Why did I just point to X here instead of actually making this point to? Right, EQ is going to fall down on this one, right? So we're saying we're pointing to x. We point to what x is bound to. We do not recreate the list structure.
Why doesn't that have the same problem the bank account did, and it evaluates x?
X is in the global environment. We're evaluating x. We're not making the problem, meaning when we evaluate y, it depends on what the value of x is.
Well, why doesn't it just replace x with the values from the list, and you end up with y pointing to a new thing? Why does y point to that same thing?
Because when we go to apply the cons here, we look at the values of the sub-expressions. The value of x is this box and pointer diagram. And we're making that the car of our con cell. So we just point to the box and pointer diagram. So in some sense, we could have the same problem if I had somehow defined x to be some sort of list structure representing my account, and then we define y to be John's account or something, I think. I'm not exactly sure.
It seems to be behaving differently. Or maybe I'm just looking at different.
Well, it's not set bang. This is just consing stuff together. So if we were to say cons 1, 2, we look at the value of 1 in the environment, look at the value of 2 in the environment, we paste them together. So those just point to the numbers 1 and 2. Look, John, head pointer. Any case, I've been told that he's bad. I'm a bad, evil person. I don't do head pointers. But anyways. So,
Holly?
Yes.
The arrow coming out of the car of y,
Yeah.
would that actually be pointing to the set of boxes down below? It's the content of the car of x, right?
No. It's the cons of x, the coulter of x. X, the coulter of x. But I still haven't answered your question. Okay, so we're consing two things together.
Right.
Okay? And so we build a con cell to cons two things together, which is what this box and pointer is over here, this little cell. This is a con cell. And the first element the con cell is going to point to is going to be x.
Why isn't x evaluated?
X is evaluated. X is evaluated to be this box and pointer diagram.
So x is a pointer?
X is bound to this box and pointer diagram, yes. X is a list of lists, right? And we represent that as a box and pointer diagram. So X is bound to this structure here. So therefore, if I was setting the car of my new con structure to be X, I point to what X is bound to. I bind to what X was bound to. I don't create a new structure. I just bind to what X is.
So x is not the list itself. X is something that points to the list. Because if that was defined...
X is bound to be the list.
Could we perhaps be clear if you just evaluate it out?
Well, but if you evaluate that, what is x?
X. So if I ask to print, okay. So if I ask to print X, well, X is this thing here. It's a list of two elements, where the first element is the list AB, and where the second part of it is the list CD.
Okay, so then why isn't that just evaluated into there, and I get a new list instead of an old list, instead of the same old list?
X is evaluated there, but the list isn't copied. So X is evaluated here. X is evaluated to be this list. Well, that's just the printing representation. This is the internal representation. It's evaluated to be that, and we bind the first pointer of our con cell to that.
So if we just defined y as x, and we made a change to x, y would reflect that change.
Right. Well, let me call it z so that we don't start confusing our letters. But sure, if we define z to be x, and this looks a lot like an exam question now, then we have z doing that, right? This looks a lot like something that you guys were asked on the quiz, right? Because then we started asking if things are EQ, EQV, or equal. And it had everything to do with, do they have the same box and pointer structure or not?
If x was not a list, though, this would behave differently. If x, well, that's symbols and numbers. If x was it was defined as 1.4, then they would be two different 1.4s.
Well, you're going to use 4 that's gonna reflect the
Well-
change back to the other variable.
It's not like we can change a number, right?
Right.
So, I mean, numbers are numbers. We can't redefine them. So we can, in fact, we can sort of make the shortcut of writing them as two different numbers. But 1.4 in scheme is 1.4. But actually, it may not be. Because EQ thing on numbers, right? So we don't exactly know how numbers work inside scheme. But with a number, we sort of take a shorthand and we just recopy the number over. But with the box and pointer diagram, because of EQ, we don't do any sort of shorthands like that. It is going to point to the same box and pointer diagram.
If you define x to be 1.3 and you define z to be x,
Can we let's do A and B now. I just don't want to get into too many variables. And B to be what?
a, and then you set bang a to be whatever, 2. Then you print out B. Is it 2?
Or is it 1.3? Well, but why isn't A evaluated to 1.3?
Is it 2?
No, B is still 1.3, you haven't reevaluated.
You failed.
That this is going to be 1.3 when we do the binding here. 1.3 goes in. We get the special behavior on box and pointer structures.
That's what you did.
Right. I mean, that's okay. So the answer is yes. It's different.
Yes, it's different. Let me give you the answer you want. Yes.
Just out of curiosity, on the left side half of the board, after setting the define y so that we, got the y pointing to x, if we redefined x to be the coulter of x, would y would still be the same, but x would just point at the coulter of where x is, or would that just completely mess things up?
Write this over here. So now if we say define x to be the coulter of x.
It's redefining it.
It's redefining x.
And y would remain unchanged.
Y is going to remain unchanged. Because these bindings here occurred at the time of evaluation. Okay, but instead of doing it that way, what if we did a set car bang or set coulter bang? So let me do a set car bang of x to be, quote, h. What happens? Well, what set car bang does is it finds the car of the item, in this case x, so the car is this, and it's going to replace that with our new value. So in this case, the symbol h. So all of that list structure goes away. It's h. In fact, it doesn't just go away. Okay? The pointer to it is lost, but the structure's still there until it's garbage collected. We'll talk about garbage collection at the very end of the class. So like in another week and a half, we'll talk about garbage collection. So now I changed the car of x to be h, and I have in effect changed y. Right? So now if I ask to print out x, it's going to return the list what? Okay, and if I ask for y, what do I get? Well, the car is h. That's the car.
More list inside with CD.
Yeah. No, that's top list structure. But there is one list on. No, that's right. All right, so if we were to redraw this a little bit more like the standard notation that we've been using. So y is going to point to the car points to h. D, and the coulter points to this. I am rewriting this merely to make it easier to read. This would not happen in Scheme. We would not create new box and pointer diagrams. That's why. So the Y is a list of 2 elements at the top, where the first element is the list of 2 elements H and the list CD. And the second is the list CD. Notice how it's easier to read box and pointer diagrams when they're drawn properly. I graded that question. Okay, so if you draw the list nice and neat across, it's a lot easier to read. Check. Got that? Got that. Okay. Set could or bang works the same as set car bang. What if I now set could or bang of Y to nil? Whack. What's Y now? Right, so list X. Okay, so that's Y now. So this allows us to mutate lists using the set car bang, set could or bang, and this is going to allow us to do neat things. I know that John showed you guys queues, represent them as lists, but without having mutation. And they got pretty hairy, right? Wasn't quite so simple, wasn't quite so nice. So, do you guys want to do queues now, or you want to put them off to recitation? Recitation? Okay. John will show you guys queues and recitation today.